So, welcome to another session on coordination compounds. Here in this whole playlist, we are solving questions of JE, which were asked in JE earlier. And again, this is a very good question, and it is all about the hybridization geometry of the coordination complexes. I hope this one question will itself help you to understand, and it will help you to clear all your doubts in this concept. This is a very concept driven question, so I'll be trying it to solve the way conceptually. So going with the first option, we are supposed to find the hybridization K2NiCN4. K2NiCN4. K2 is a positively charged ion. So if it leaves, it will have a -2 charge on NiCN4. So the oxidation number of Ni can be calculated as X. Cn is negative, so minus of 4 equals to -2. So here we get X is equal to 2, right? So we have X is equal to 2. So Ni is in +2 oxidation state. So the electronic configuration will be Ar3d8. Otherwise, in normal form, that is Ni is in Ar3d8 4s2. So this 2 is not there in +2 oxidation state, and so we have Ni Ar3d8. So we have 8 electrons in the valence d orbital. So if I draw it this way, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So this will be the configuration, right? The noteworthy thing here is about the complex of the ligand is Cn. Cn is a strong field ligand. So what will this cause? It will cause pairing. Strong field ligand causes pairing because it is strong. It forces the electron to move from this orbital to this orbital. So it will be here, and this orbital will be free. In the next say energy level, we have 3D, we have 4s, and we have 4p, right? 4p. So we want to fit four ligands, four bonds. We are supposed to make one from D, one from S, and two from P. So the hybridization is DsP2, right? So we have DsP2. Okay, DsP2 is a square planar geometry. Again, it can be also asked. Going on to the next option, that is NiCO4. Similar to the earlier problem, we have NiCO4. NiCO4. Now there is no other thing. So here Ni is in the normal state, that is oxidation number is 0. So we have 3D8 4s2, and we have the ligand CO. Again, a noteworthy thing is CO is also a strong field ligand. So what will this cause? So again, if we see 1, 2, 3, and this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, and we have this, right? So we have electrons here. So these electrons will move here because it is a strong field ligand. And in this case, we will have an sp3 hybridization, and hence the geometry will be tetrahedral. Okay, even if you don't understand like what to do, one thing you can always do is eliminate the options. So if we see carefully, A3 is given in three options. A in the C option it is given as A as 1. So this is for sure not going to be the right answer. So if you are not sure about the B, you can try about C and D. Then you can try that method also. So going on to the next C, that is CONH3 Cl3. So if you see Cl3 is here, so it will have, if one Cl is removed, it will have a -3 charge on the complex. So CONH3 and CONH3, okay, with the +3 charge. NH3 is always a chargeless, or can say neutral ligand. So there is no scope of any charge. So the oxidation number here is simply +3 for the CO, and hence CO in +3 oxidation state will have 6 electrons in the valence shell. 1, 2, 3, 4, 5, 6. Right. Now NH3 is a moderate ligand. It is not either strong or weak, but still it will cause pairing of these electrons, and hence these two orbitals will be free. So two from the D, one from the S, and three. 1, 2, 3, 4, 5, 6. Two from D, one from S, and three from P. D2sp3 will be the hybridization in CO. Right. Again, if you see the next option, let's go and see the next option. Option number D, that is Na3COF6. Fluorine is a weak field ligand, so it cannot cause pairing, right? So if you solve for NaCOF6, Na3, so you have CO in +3 oxidation state. Again, you have 1, 2, 3, 4, 5, and 6 electrons. But here the problem is you have a weak field ligand. This is a weak field ligand, so it cannot cause pairing. So what will happen? The hybridization that will occur from 4s to 4p and the next d orbital. So it will be sp3d2 and not d2sp3. The only reason that is here is because of the ligands that are acting. Same coordination number, same oxidation number, but different result. This will also cause octahedral geometry. This also cause octahedral geometry. So that is for sure. Octahedral is sure. The only difference is between the hybridization. This D2, which is in the last, it is called uh, outer shell hybridization, where outer d orbital is used, and here it is an inner d orbital. So that is the key difference. And if you see, this is very identical if you have basic knowledge about the subject or the topic. By only A and D option, you can try, because see, if you know the A option is 3, D option is 2 for sure. 2 because this is a weak field ligand sp3d2 and dsp2. Even if you know A and D, you can solve the sum. That's it. Thank you.